Visualizing 3D shapes. In this module, you will learn about visualizing 3D shapes. We live in a three-dimensional world. Every object we see or touch has 3 dimensions that can be measured by length, width, and height. For example, a television has 3 dimensions that can be measured by length, width, and height, and so on. Every object that we see has different views, and this view depends on the direction from which we are looking at the object. The different types of views are top view, side view, and front view. Now let us see the different views of a dice. Top view of a dice, side view of a dice, front view of a dice. Similarly, here is different views of a car. Top view, side view, front view. Observe the solid shapes which are formed by arranging some units of cubes. It looks different from different position, but the object is same. First, let us see different views of solids made of 3 cubes. Its top view, side view, and front view. Now let's see solid shape made of 4 cubes. Let us see the front view, side view, and top view of some more objects. We use map since we were in primary class. We use maps to find a particular location, rivers, mountain, etc. Here is a map drawn by Simi. In this map, the route from her house to her friend's house is shown. Can you find out how far is Simi's house from her friend's house? It is very difficult to answer the above questions on the basis of the given map, as we do not know if the distances between the circles. There is no proper information in this map. Now, let's have a look at this map drawn by her brother, Sahil. Sahil uses different symbols for different landmarks. Longer lines have been drawn for longer distance, and short lines have been used for shorter distance. He has drawn a map with a scale. Symbols and distances will help us to read the map easily. The actual distance is denoted by 1 centimeter or 1 millimeter in the map. This means if one draws a map, he or she has to decide that 1 centimeter space in the map shows certain distance, say 1 kilometer or 10 kilometers. This scale will vary from map to map and not within the map. Let us learn about polyhedron. Each of the solids is made up of polygonal regions, which are called its faces. These faces meet at edges, which are line segments, and the edges meet at vertices, which are points. Such solids are called polyhedrons. A polyhedron is a solid with flat faces, and curved or lateral surfaces are non-polyhedron. Cubes, cuboids, prisms are few examples of polyhedrons. Spheres, cones, and cylinders are a few examples of non-polyhedrons. The faces of cubes are squares. The faces of rectangular prism are rectangles. Hence, these solids are polyhedron. The surface of sphere is curved. The surface of cone and cylinder is lateral. Hence, they are called non-polyhedron. Polyhedron can be classified into convex and non-convex polyhedron, and regular and non-regular polyhedron. First, let's learn about convex and non-convex polyhedrons. If the line segment joining any 2 points on the surface of the polyhedron lies on the surface and does not intersect itself, it is called convex polyhedron. The idea of convex polyhedron is similar to convex polygon, and if the line segment joining any 2 points on the surface of the polyhedron does not lie on the surface, then it is called as non-convex polyhedron. Now let us see regular polyhedrons and non-regular polyhedron. The polyhedron whose faces are made up of regular polygon and are congruent and the same number of faces meet at each vertex is said to be regular polyhedrons. For example, cube is a regular polyhedron. Its faces are congruent, regular polygons. Vertices are formed by the same number of faces. More examples of convex polyhedron are tetrahedron, octahedron, dodecahedron, and icosahedrons are regular polyhedron. Now look at this square pyramid. This polyhedron is not regular. All the sides are congruent, but its vertices are not formed by the same number of faces. One vertex is formed by 4 edges, and other vertices are formed by 3 edges. A prism is a polyhedron in which 2 faces are parallel and congruent polygons, called its bases, and whose other faces are parallelograms, called its lateral faces. There are many types of prisms. The type of prism is determined by the shape of the base. For example, a triangular prism will have triangular bases, while a square prism will have square bases. A hexagonal prism will have hexagonal bases, and so on. On the other hand, a pyramid is a polyhedron for which one face, called the base, is a polygon, and all other faces, called lateral faces, are triangles. If the base is called the bottom of the pyramid, the top point is called its apex. As with prisms, there are many types of pyramids, often classified by the shapes of their bases. For example, a triangular pyramid will have triangular bases, while a square pyramid will have square bases. A pentagonal pyramid will have pentagon bases, and so on. Have you ever heard about Eulers Formula? For many solid shapes, the number of faces plus the number of vertices minus the number of edges always equals 2. This can be written as F plus V minus E is equal to 2. In fact, this formula is true for any polyhedron. No matter what we do, we always end up with 2. Let's try it on the cuboid. A cuboid has 6 faces, 8 vertices and 12 edges. So 6 plus 8 minus 12 is equal to 2. Now let's tabulate the number of faces, edges and vertices for the following polyhedron. Here, F stands for number of faces, V stands for number of vertices, and E stands for number of edges. From the last 2 columns, we find that F plus V is equal to E plus 2. Therefore, F plus V minus E is equal to 2. As we know, this relation is called Eulers Formula. Let us revise all that we learned in this module on visualizing 3D shapes.